Okay, so on this section I'm going to talk about chip loads and feed speeds, and this is something that your tool supplier is going to be much more aware of than what you as a contractor or a cabinet maker, but it's good for you to know about it. When you put an order in for a cutting tool, one of the things that your tool supplier will do, they'll ask you a lot of questions about where you're using it and what type of material. So what they're trying to do is figure out basically the feed rate that you want to work at, how much controlled pressure and so on, and they want to give you the best tool for the money that you're spending. If we have the tool the chip load properly set up, when I talk about chip load, it's how much material you're actually removing for every revolution of that blade on every single knife, and depending on the quality of cut that you're trying to get, that chip load is going to vary. So the chip load is critical because if the chip is the proper size, the chip will carry away the heat, promoting long tool life, and that dissolving that heat buildup is a big factor in the performance of that tool. Too high of a chip load will cause an unsatisfactory edge finish or part movement, as well as excessive wear on the spindle and the bearings. And this is something I talk about quite often on my demonstrations. I'll ask you to pay attention to the amp gauges on those machines, especially on the sanders and on the shapers and so on. If you're working that machine too hard, you will cause some damage to the bearings. You will cause some damage to the motor. So we can move forward there. To increase the chip load, you can increase the feed rate, you can decrease the RPM, and we can use less flutes. When we use less flutes, we bring the price of that tool down. Instead of a 3-wing cutter, maybe we can get away with a 2-wing cutter. Or maybe if we want to get a better tool chip count, then we may want to add another wing onto that cutter, make it a 4-wing cutter. In some cases, we have 8-wing cutters in our tool crib. If we want to decrease the chip load, we want to decrease the feed rate, we want to increase the RPM, or we want to add more flutes. And when we do add more flutes, that's going to add more cost to that tool. It may not be the right thing, it may not be the wrong thing. It's just whatever's needed to do the performance or do that job that you're trying to do. The number of knives in that cutter will influence that chip load. The depth of cut, 1 times D, 1 times the diameter, use the recommended chip load. So they're talking about the cutting edge itself. If you have a 1-wing cutter, and there's no such thing as a 1-wing cutter on a shaper, but you can find 1-wing cutters on a router bit. If we add in that 2nd wing or that 2nd cutting edge, you reduce the chip load by 25%. If we add in a 3rd cutting edge or a 3rd wing, you reduce that chip load by 50%. So every time you add another wing, you're improving the quality of the cut. And these are the recommendations that they take into account for depending on the quality of the finish that you're aiming for. If it's furniture, we're looking for 0.012 cutting edge to 0.032, and what that translates to roughly a 64th of an inch to a 32nd of an inch being removed for every wing, for every cutter as it rolls or rotates. If it's a mill finish is going to be roughly a 32nd to a 16th. So mill work would be a lower RPM, lower knife cut per inch count than what we look for in furniture finish. On furniture finish, we're looking for roughly 16 to 18 knife cuts per inch. For mill work, we're looking for 12 to 14, and for hogging, for rough cutting, we can work within a 16th to 3/32. And that's the 0.1 inches to the 0.2 for hogging. When we talk about hogging, we're talking about rough cutting something out. Chip load calculation, and again, this is the formula that your tool suppliers will be working with. They need to know the feed rate. When they talk to you, they will ask you what feed rate. They'll ask you, first of all, what type of machine you're using it on. So based on that, they can pull up information as to the feed ranges what type of motors and so on, what size of motors are on that machine, and they may ask you that question as well. They may ask what your suggestion is as far as that cutting edges that you need, but really it's up to them as to what they design. And that's a negotiated point when you're buying your tool. If they recommend you need a 4-wing cutter, well, let's redo the math and give me a price on a 3-wing cutter. It may be an opportunity to save a little bit of money. So cutting edges, flutes, knives, feed rate is usually given in feet per minute. So they will be asking you these questions when they're designing that tool before they send it to their engineering department. They may give you a rough quote and then go back and try to design the tool around that quote. So I think we're going to stop here. Thank you.